Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out there are tons of things that can go wrong during a planet's formation, like locking up to the sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our Sun, growing bigger by gathering gas and rocks like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our Sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the Sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the Sun and nearby planets pulled them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star while the other side remains in perpetual darkness. So one side is always very hot while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our Sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them, there might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and two planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its two giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought. Studying them will help us learn more about the history of planet formation.
The universe is three-dimensional. Okay. No, the universe is four-dimensional. 3 dimensions for space and 1 for time. Okay, duh. What are you talking about? The universe has 9 dimensions. Okay. Come on, guys. The universe is flat. Wait, what? However strange it may sound, all these statements are kinda true. How come? The theory of general relativity allows for the universe to take one of 3 forms. It can be flat, like a sheet of paper. It can be completely closed, like a sphere. Or it can be shaped like a horse's saddle. It's very important to figure out the shape of the universe. This way, we can learn about its past and future. It can answer crucial questions. Is the universe going to expand forever, or will it eventually collapse? Is it finite or infinite? Here, we need to consider two factors: the density of the universe and the rate of its expansion. Now, hear me out. About 68% of the universe is dark energy, 27% is dark matter, and the remainder is normal matter. That's what stars, planets, and our bodies are made of. And when we speak about the universe's density, we mean the amount of matter packed into a given volume of space. And the density of the universe is so great that its gravity is more powerful than the force of its expansion. Then the universe will curl into a sphere. This is what we call the closed model. The coolest thing about such a universe? Even though it is finite, it has no bounds. However paradoxical it may sound, if you found yourself in this universe, you would travel its space forever without falling over an edge or hitting a wall. But if the density of the universe was low, it would be unable to stop its expansion. In this case, space will warp in the opposite direction, creating an open universe shaped like a saddle. But the most popular theory, and the most bizarre-sounding one, is that the universe is flat. It might be possible if its density is just right, and it expands in every direction without curving negatively or positively. Scientists claim that it's the most plausible scenario, by the way. So, if you're disappointed by our planet's roundness, the flat universe might come as some consolation. But what does a flat universe mean? I mean, our 3D world seems very real. Can it be just an illusion? Nah. The flatness of the universe isn't that two-dimensional flatness you might be imagining right now. To help you understand this concept better, I'll tell you this. In a flat universe, two rockets flying next to each other will always remain parallel. In a closed universe, their paths will diverge, and they will follow the curvature of space and eventually make a loop and meet where they started. And in an open universe, these rockets will separate and never come across each other again. Of course, it'll take a lot of time to prove that the universe is indeed flat. But so far, astronomers don't have even the slightest reason to doubt this theory. All the data they have is consistent with this flatness. For example, the imprints left on galaxies from sound waves that occurred right after the Big Bang also support this theory. In other words, right now, scientists agree that the universe we live in is like a three-dimensional sheet of paper. Good luck trying to imagine this. But if this idea is wrong and the universe is actually curved, it must be ginormous. Because those 93 billion light-years we can observe aren't a large enough portion to let us see even a tiny curvature. So, it might be wrong to say the universe is flat. It's probably better to announce that the little bit of the universe we see is flat.
I've been waiting for this moment for so long! Now no one will say I'm old and bald! Oh. Oh. I'm too old for this. Hey, son! What's got your panties in a twist? It's the universe! She's trying to set me up with another star! Again! That bad, huh? Why don't you try to talk to her and ask her not to do it again? Because I can't find her! She's hiding! So, I've got to find...
And you won't succeed. Unless you very politely ask me for help.
Well, Mr. Detective, would you be so kind as to help me?
So, where would you hide if you were a slightly insane flat woman?
Flat? What are these?
Aren't they cool? Those are 2D glasses. Otherwise, how would you see the flat universe? Come, let's look for it.
Duh.
Anyway, haven't you heard that no one actually knows what the universe looks like? But the most popular theory is that it's flat.
Flat?
The universe seems to be expanding in every direction, without curving positively or negatively.
She is expanding? I'm doomed! Her matchmaking skills are terrible!
Or maybe we shouldn't think like a flat universe. Maybe we should try to figure out where a donut-shaped universe can hide.
Now donut-shaped? Really?
Yes, the universe may have a torus shape, and is curved in such a way that it connects back on itself like a donut. There's one more theory, but you aren't gonna like it.
Try me, Mercury.
Well, so there might be many parallel universes, and we live in only one of them.
Oh, come on, calm down. That's surely not the worst thing you have been called, huh?
No, seriously, have you heard that? They called me flat! Flat! Like Venus!
Hey, I've heard that.
I tell you, Earth is flat. I've been to its edge and looked over it. Okay, let's imagine I was flat. To be shaped like a disc, a cosmic body needs to spin incredibly fast. But this would tear everything off the planet. It could even rip this space body apart. Ouch! It's too hot in here! And stop tickling me! Let's say some huge pressure made me flat, which is not my dream scenario, by the way. But this shape wouldn't last long. The force of my gravity would shape me back into a sphere in no time. Planets are spheres because gravity affects them equally from all sides.
And if there was no gravity?
You won't like it, but I'll show you anyway since you asked so nicely. So, if there was no gravity, there would be no atmosphere, since there would be nothing to keep it in place.
What's going on?
I don't know. But that's not all. If I didn't have gravity, you'd be gone too. Lost in space. Absolutely alone.
Stop it!
Well, you did want to know. And the last thing. So, if I was flat, then how can people explain the fact that I have the core, the mantle, and the crust? My core produces a magnetic field, which protects humans from the solar wind.
Listen.
But what if Earth is actually a sphere? Uh-oh.
The hardest thing on the planet is to get out of a warm bed early in the morning. The second most challenging thing in the world is to sit in an office and force yourself to start working. It's hard to read a big book and cook your own food. It's almost impossible to earn a lot of money. Do sports? It's something fantastic. Keeping a dog at home and walking it several times a day is just senseless. How do people live this tough life? Almost every day, Lewis thinks about these things, and he is the laziest person in the world who loves only one thing: watching TV series and movies. So, one day, he wakes up in a 2D flat body. The volume of his muscles and bones has decreased by almost 99%. He can't turn off the alarm because his body is too thin and barely emits heat. Under the loud ringing of sirens, he tries to pull off the blanket, but it's too heavy. Lewis crawls out of bed. He looks at himself in the mirror in horror, stands sideways, and becomes almost invisible. He tries to scream, but his voice sounds like a mosquito squeak. The fridge door is as heavy as the door in a bank vault. An apple on the table weighs like a barbell. Louis needs to go to the toilet, but can't press the handle. Fortunately, he's thin enough to squeeze through the gap between the door and the wall. He has to go to work, but he has to eat something first. He sees the breadcrumbs he hasn't cleaned up from last night's dinner. He picks up and swallows a couple of them. His stomach is super small now, so 2 tiny crumbs seem as heavy as 2 plates of spaghetti. Now he needs to drink some water. All the bottles are closed, and he doesn't have the strength to unscrew the lids. Fortunately, water is dripping from the tap. Louis drinks just 1 drop, but feels like he's had 2 cans of soda. He leaves the house, runs across the road, and gets under a car. Our guy is invisible to the driver because he's standing sideways. But thanks to his light weight, Louis doesn't get any damage. He flies off to the side, but he can't land anymore. The wind blows and lifts Louis up. He tries to hold on to the lampposts and traffic lights, but his thin hands are too weak. The wind is taking him higher and higher. Louis flies past the birds and the top floors. The temperature is getting too cold for his body. He freezes, but the wind changes its direction and takes him down. Someone throws a banana peel out the window. Louis grabs it and uses it to descend safely. He finally reaches the road and ties the banana peel to his laces. He's walking slowly, since it's hard. The peel seems as heavy as a cart loaded with bricks. He crosses the street and falls every time people push him on the shoulder. Louis screams back at them, but they don't even hear him. Exhausted, he gets to his office. The boss scolds Louis for being late. Louis's tiny ears are now sensitive to all sound waves, so the boss's words seem very loud and low, as if they come from a large speaker. The boss doesn't care that Louis is flat. He wants all the work done. Louis tries to take a stack of papers, but it's too heavy, so he moves 1 sheet at a time to his desk. Each page weighs like 10 skateboards for him. Louis moves 3 documents and feels like he's run a marathon. Then he sits at the computer, but the keyboard doesn't work. The keys don't get enough load. Louis has to put a lot of effort into printing something. It's the end of the day, and Louis has done only 1% of all the work. He comes to the office kitchen, sees a delicious sandwich, but can't bite it off completely. He breaks off tiny pieces of salad and bread. It makes him full. He notices that his hair is covered with frost. An icicle is growing on the tip of his nose. Why has the ice age begun in the office? Oh, it's just the air conditioner lowered the temperature by 1 degree. But our hero is sensitive to the slightest fluctuations in the air. Exhausted, he leaves the office and enters the elevator. A crowd of people presses him from all sides. A drop of sweat from one guy's neck falls right on Louis. Like a sheet of paper, he absorbs almost the entire drop. The elevator doors open, and Louis gets out quickly. He runs out into the street. The wind is pretty strong, but the banana peel keeps him on the ground. It starts to rain. Just a few drops fall on the ground, but Louis gets soaked through. Seconds later, Louis feels like he's standing under a waterfall. It's hard to walk. He unhooks the peel and falls exhausted to the ground. He wakes up a couple of hours later. The sun is shining through the clouds. Louis is completely dry. He feels like he's in the middle of a desert. He tries to raise his hand, but his skin is so dry that it hurts. At this moment, a street dog approaches him. It licks Louis from head to toe. He stands up, pets the dog, and goes home. The animal follows him. He squeezes into the apartment under the door and falls into bed. The next morning, the alarm clock sounds too loud. Louis tries to turn it off and feels terrible pain all over his body. His muscles got a huge load yesterday. Louis wants to scream, but he can't, so he cries. He's terrified that he literally can't do anything. He spends several days in bed and gets up only to use the bathroom and to fill his stomach with breadcrumbs and tap water. At some point, he realizes he can no longer live like this. He misses ordinary food, delicious drinks, and a normal lifestyle. He decides to work out. Every day he does push-ups, squats, and pull-ups. His muscles are not so thin anymore. And now, after 2 months of hard training, he can lift up the laptop lid. At work, he carries 3 sheets of paper to his desk at a time and can type 200 words a day. He reads every document and understands that his job isn't that boring and pointless. The boss notices Lewis is motivated and raises his salary. Our hero tears off small pieces of vegetables and ham from other people's sandwiches, but he believes that he will cook his own sooner or later. Every day, the dog accompanies him from home to work. When the wind is strong, he grabs onto its fur. He's strong enough to unlock the door again, which means he can let the dog inside his house. Daily workouts and perseverance make Lewis happy. He feels better than at the time he had a normal body. An active lifestyle inspires Lewis to read more books. It turns out that literature is exciting. And so, one day, he wakes up in 3D. He feels like a superhero, ready to become the best chef in the world, earn a lot of money, and win an Olympic medal in any sport. He can do anything. Why didn't he appreciate it before? Now, life seems fascinating and full of meaning. But now, he's about to turn on the laptop to start watching a new TV show. 1 episode first, and all the achievements later, he thinks. Lewis used to put a lot of effort into opening the lid when he was in 2D. So now, he accidentally breaks the computer. Good for him. He realizes that it was a laziness trap, so he won't go there again.
The Milky Way is one of the biggest mysteries out there, literally. It's hard to figure out how big our home galaxy is, and one of the main reasons is because we live in it. Think of it as walking around a mall. You can tell it's big, but you can't be certain until you actually see it from a bird's eye view. The Milky Way consists of billions of distant stars that look like a string of lights from afar. So you just need to measure the distance between these stars and voila, you have the answer. Not really. I might have forgotten to mention opaque clouds of dust blocking your view. Some scientists were stubborn enough to run computer models of how galaxies form and evolve. There's a halo around our galaxy, so the scientists wanted to see if there was some sort of a dead end in the Milky Way. They found out that the Milky Way spreads for 100,000 light-years away from its center. It likely means that the entire galaxy is around 200,000 light-years across. The problem with this estimation is that halos don't tend to have some final border since they simply fade away. It's like pointing a flashlight and trying to see precisely where the light ends. In 2013, the Hubble Space Telescope captured an image of something 25 million light-years away. It turned out to be a spiral galaxy, later called ESO 3738, with at least 7 other galactic neighbors. And this galaxy is as thin as a pancake, a very shiny pancake. The telescope also took a photo of another galaxy cluster 65 million light-years away. It was called IC 335. It's another glorious glittering pancake floating in the vastness of space. The images the telescope took aren't the most accurate. It's hard to tell what exactly you're looking at. These disk galaxies have lots of dust clouds that can stretch for hundreds of light-years across. They're mainly located near the centers of galaxies and are invisible in regular light, but they can be detected with the help of a blue filter. Anyway, this IC 335 galaxy is an oval disk with huge clouds of gas and dust. This means stars constantly appear there. But not all galaxies create stars. A galaxy is born as a giant ball of slowly rotating gas that is steadily collapsing in on itself. As it starts spinning faster and faster, the pancake shape is formed. Ooh, pass me the syrup. It's like spinning pizza dough in the air after rolling it into a ball. The topping is stars, and the sauce is clouds of dust and gas. Are you getting hungry like me? Some galaxies can lose their gas and dust if they become part of a galaxy cluster. Then all these mini-galaxies orbit their common center of mass, with gas separating them. When a disk galaxy dashes through them like a speeding train, the pressure can blow away this dust and gas. From far away, it looks like you're staring at a DVD you're about to play. But if you traveled millions of light years to get a closer look, you'd see a dim disk filled with stars. You wouldn't even be able to tell you're inside it. You'd also see a bright blob of dust left by the red giants in the middle of the galaxy. Red giants are massive and very bright stars with low surface temperatures. But the images of these galaxies don't actually show us their real color. Cameras make up some of these hues so that you don't have to look at something fuzzy or grainy. People don't actually know the real colors of distant galaxies. Our galaxy has a lot of gas inside, like me, so we don't need to expect our home to dry up anytime soon. In fact, the Milky Way still produces new stars, around 7 a year. But some galaxies fade out when they can no longer create stars. In the industry, they call it strangulation, and it happens when galaxies run out of gas, which means there's no more new material that can be used for star making. Gas and dust aren't the only things you can find in a galaxy. Just like a magician pulling a rabbit, flowers, or other things out of their magic hat, galaxies have other surprises, like planets, those balls of matter spinning around themselves and around other things. Well, technically, planets are far from being perfectly round in shape, but they aren't also flat like spiral galaxies. It's mostly because of gravity. Its force is so strong that a planet pulls everything towards its center, taking the shape of a sphere. In the process, all the edges and anything else that might stick out gets smoothed out. But the smaller a space body is, the less round it is. Take a comet. It doesn't always have a smooth surface. It's small, and therefore, its edges are rugged and pointy. Given the size of Earth, it's safe to say the gravity is strong here compared to that of the Moon or any smaller-sized space object. And because of our planet's constant rotation, there's an outward bulge on Earth. This tug-of-war between the gravity pulling inward and the planet's spin doesn't allow Earth to be a perfect ball. On top of Earth not being a perfect sphere, the planet is also tilted. This design flaw is responsible for the seasons we have. This tilt could happen because millions of years after Earth was formed, it probably collided with a protoplanet, a large space body developing into a planet. Venus is unique because it rotates backward compared to the rest of its peers. If you were standing on Venus, the hottest planet in our solar system, you'd see the sun rise in the west and set in the east. But you'd have to make it on time to observe this phenomenon. A day on Venus lasts for more than 240 Earth days. For a long time, scientists believed that the sun's strong pull on Venus was responsible for such a long day. But new theory claims that Venus used to spin just like Earth and the rest of the planets. But at one point, it just flipped its axis 180 degrees. It doesn't mean the planet abruptly stopped halfway through the rotation and started to move backward. One theory suggests that a large comet or object struck the planet in the past. This might have caused it to change the direction of its rotation, but many scientists doubt this theory. If you observe the moon for some time, you may notice that it's the same face staring at you every night. The truth is that the moon does rotate, but very slowly. It takes our planet's natural satellite 27 Earth days to rotate around its axis. Plus, the moon rotates at the same rate that it orbits Earth. The side we always see is called the near side of the moon, and the side that's not facing us is, you guessed it, the far side of the moon. It also has the nickname the dark side of the moon. Uranus's rotation axis is 98 degrees relative to the plane of the solar system, which basically means that the planet spins on its side. For a while, scientists believed that a large object firing through space knocked into Uranus, causing it to tilt. But here's one problem. Uranus's moons are covered in ice. A collision so powerful that it made the planet tilt would have resulted in disrupting the moon's movement and their position. But they seem relatively untouched, and all the ice covering them is still intact. But any major changes happening with Uranus would have generated enough energy to melt the ice. Another reason for Uranus's strange position might be its rings. Yup, Uranus has rings just like Saturn, except they're lighter and fainter. Saturn's rings are mostly billions of chunks of ice and rock floating in orbit. Some particles can be the size of a pebble, while others can reach the size of a house. Wow. Other particles are broken-up comets, asteroids, and moons torn apart by Saturn's gravity. If you observe the rings from afar, they look like colorful stripes made up of thousands of different streaks, but there are actually only 8 layers of rings. Uranus might have had rings that were just as glorious as Saturn's around 4.5 billion years ago. The balance between Saturn's gravity and its rings might be responsible for keeping the planet upright so that it doesn't tilt over. If Uranus had the same rings, they could prevent the planet from toppling over. The way to solve Uranus's tilting problem might be for the planet to get its rings back. They would help Uranus keep its balance. On the other hand, hey, we like it just the way it is. A deep, deep orange sunset. Epic. You're on the deck of a cruise liner somewhere in the Atlantic. The sun dips slowly, merging with the water on the horizon. Next to it, you can see another circle. It's huge. It looks more like a new planet or a second sun, but this sphere's located on Earth. It's a balloon. Humans have been inflating it for months, and in just a few weeks, it'll be the size of our planet. Nobody knows who exactly came up with this crazy idea. Probably somebody from Brightside. It's the year 2121. People live longer and have better lives. At some point, they start to come up with weird and wacky things, not just useful ones. Hey, let's make a lake with boiling oil where we can fry potatoes 24/7. Or, what if we build a huge frozen city just for penguins? Someone suggests creating a machine that can put your consciousness into a shark or a goldfish, whatever sea creature you want, just to see what it would feel like. A couple of guys even decide to make the switch permanent. Sounds fishy to me. People discover more of outer space and create incredible, life-changing medical tech. But sometimes, humanity just wants to have fun. One day, a scientist decides to inflate a balloon the size of our planet and pop it, just to see what had happened. People are excited. It would definitely look awesome, and the pop would be insane. These kind of strange ideas pop up all the time these days. The economy, tech, agriculture, everything's developed so much. That means there's plenty of money lying around to spend on whatever's the weirdest idea at the time. The main thing now is to do stuff that's fun. And as soon as this idea comes up, billionaires around the world start throwing money at it. Who wouldn't want their name associated with just about the coolest project ever? On what looks like any normal day, scientists gather in an underground lab to talk materials. Why an underground lab? Because it's awesome! After 10 minutes, it becomes clear that there's no substance in the world that could stretch that much. So they decide to create one. Perpetual rubber. They come up with a sweet plan. They just can't build a deflated balloon the size of a continent and then slowly inflate it. That would be ridiculous. Wait, are there magnitudes of ridiculous? It's getting pretty high here. Instead, scientists decide to make a ball of rubber about the size of an SUV. Then, over the course of a whole year, they'd blow a strong stream of air into it until it was the size of Earth. Perpetual rubber can stretch forever and never tears. The rubber reacts with oxygen to divide and expand without getting popped too early. How lame would it be if it got snagged on a skyscraper and… The coolest thing about perpetual rubber is that if you hit it with a pencil or fork or whatever, it won't tear. It'll actually envelop whatever you push into it. So if we're talking about something bigger, like a car or a ship, it'll be a sort of bumper car situation. A little impact, but no biggie. Finally, months of hard work and $300 billion later, scientists unveil their masterpiece. And it kind of looks like a car-sized rock, except it's orange for some reason, don't ask me why. The experiment begins in the most remote part of the Pacific Ocean, on an artificially created island. Here's where it gets more ridiculous. Wait, I mean interesting. While half the scientists are messing around with rubber, the other half were busy building the world's biggest turbine, a turbine strong enough to pump air into the largest balloon of all time. The turbine extracts oxygen out of, well, air, heats it, and pushes it into the ball of rubber. Sounds simple enough, right? Not really. This turbine eats up energy like me at a Sunday buffet. You know, the kind with prime rib, shrimp and seafood, all kinds of pasta, and a dessert bar so big you can't see the end of it, and oops, I got carried away there. Anyway, the turbine, It takes a whole team of solar, wind, and wave-powered generators to make it run. The final countdown begins. 10, 9. About 100 people grab the rubber ball from all sides and start to stretch it out over the mouth of the turbine. 8, 7. After fastening it to the turbine, it's helicopter time. 4 huge choppers grab hold of the rubber and start to stretch it up into the sky. 6, 5, 4. The rubber's stretching out beautifully. This thing actually might work. 3, 2, 1. Launch. Somebody flips the switch and the turbine turns on. Whoosh. The turbine gathers speed and starts to pump oxygen directly into the outstretched rubber. After just a few days, the ball's already bigger than the island itself. From far away, it already starts to look like another planet or sun. Photographers go nuts. Every day, the ball gets bigger and bigger. Its edges reach the nearest coastal cities. Every morning, people come out of their homes and watch an orange rubber ball block out part of the sky. The turbine pumps oxygen into the balloon 24/7, and pretty soon it starts to float up ever so slightly. Next to the island, it becomes difficult to breathe. And what's going to happen when all our oxygen is inside that giant balloon? Whoops. The scientists didn't think that far ahead. Luckily, it's 2021, so tech moves pretty quickly to come up with a solution. Engineers submerge billions of tons of 3D printed phytoplankton and seaweed into the Pacific Ocean. These organisms are some of the Earth's main suppliers of clean air. They make oxygen the same way trees and plants do. By now, people are already used to walking the streets, watching the endless rubber sky. At first, it's all fun and selfies. Then, international flights over the Pacific start getting canceled or rerouted. It's actually faster to go from Beijing to LA by going the other way around the world on a bunch of ultra-high-speed underground trains. The higher the balloon rises, the faster it inflates. Something about the difference between internal and external pressure on the balloon. Basically now, the turbine doesn't eat up as much juice as before, which is good because it's the most energy-intensive piece of equipment humanity's ever built. After a few more months, low-flying satellites start to crash into the ball and gently bounce off unharmed. There are only a few days left before P-Day, the day everyone gets to witness the greatest pop of all time. Inside the balloon, something crazy's happening. The simplest forms of life are starting to take shape. And there's something these organisms and humanity have in common. We also live in a universe that's constantly expanding. Maybe the universe is just one big balloon, created by some cosmic race that loves big bangs. Ooh, hope they don't get the urge to pop it. The balloon rises higher than ever into the sky, and it's time for the final step. The turbine switches off, and the balloon is sealed shut. The Pacific winds blow the balloon east. It flies over megacities, forests, canyons, and floats low enough to the ground that people can even climb up on the roof and feel the ball with their hands. Some brave, or crazy people, pack on the layers, strap on a parachute, and put on special rubber climbing gloves. They scramble up the side of the balloon until they reach the top. It's a sky-high monster trampoline. When they get enough viral views, they run, jump, and open their parachutes. When it rains, the balloon deflects all the droplets into a single massive stream of water. You do not want to get a faceful of that. But that's not the worst part. The Earth's magnetic field gets disrupted, and the 3D printed phytoplankton just can't produce enough oxygen anymore. People find it difficult to breathe, but everyone agrees this thing was totally worth it. Animals go mad, and birds get super confused and start migrating to random parts of the globe. The sphere is slowly breaking away from the Earth's atmosphere. It's about to go into space. The live feed from the International Space Station confirms it. The balloon is the same size as Earth. Let's do it! It's time to pop this thing before it starts playing interplanetary pinball. Humanity holds its breath. The penguins in the ice city look up into the sky and fall backwards uncontrollably. The people that decide to turn into sharks and stuff poke their heads out of the water. Everyone's waiting. To pop it, scientists use a powerful laser. It's the big moment. Let's take a second. Big deep breaths. Okay, go time. The laser fires up and blasts a liquid hot stream of light particles directly at the balloon. The heat is palpable. The rubber starts to change color. It's going to burst open any second. Wait, this could end badly. Who cares? A huge amount of oxygen bursts into the Earth's atmosphere. It wipes away the clouds, leaving a perfect blue sky. But the most impressive thing is the sound. It just isn't. Everybody was jazzed up for an epic sound explosion. Nothing. Maybe a little... But that was it. Said some guy. I like the shark thing better.
Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty bam! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases. Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during the second experiment. Nope, not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.
So Venus and Earth are so different that a foolish question like, what's longer, a day or a year, that makes absolutely no sense on Earth, totally makes sense on Venus. A day on Venus is indeed longer than a year. If we put it into Earth's perspective, a day on Venus would equal 243 Earth days, while a year would only last 225 days. So it's like your birthday is every day. Venus is often nicknamed Earth's evil twin. Their differences are so stark, you'd think they're from different galaxies altogether. Just to give you an idea of how far apart they are, if the day-to-year ratio wasn't enough, the Earth rises in the west on Venus but sets in the east. These days, one of the very few similarities between these two is their size. But try to imagine a time when Venus and Earth were like peas in a pod, besties since the beginning of the solar system. Venus used to be the life of the party. NASA scientists think Venus might have even hosted a liquid water ocean and surface temperatures that could have welcomed life for up to 2 billion years. But modern-day Venus is a different story. We're talking extreme temperatures and a thick carbon dioxide atmosphere. So, what led to this cosmic makeover? Size, location, and attitude. I mean that the distance from the Sun and internal heat played a huge role in shaping Venus and Earth's destinies. By the way, there used to be 3 siblings that could have hosted life: Venus, Earth, and Mars. Now imagine 3 cupcakes in an oven. Once they were fully baked, they were taken out of the oven. One of them was put in front of an open window in the middle of winter. Another was carefully placed on a table and covered with a nice clean kitchen towel. And the last one was accidentally forgotten and left in the oven. Oops. Mars, Earth, and Venus are like those cupcakes. Mars got too cold and not welcoming. Earth is still nice and warm and well protected from all the unpleasant things, just like the towel protects that lucky cupcake. And Venus got scorching hot and impossible to consume. In terms of development, Earth took the slow and steady route, maintaining its oceans, stable atmosphere, and biodiversity. Venus, on the other hand, cranked up the temperature, evaporated its oceans, and went all in with greenhouse gases. As a result, we have a planet where you'll melt faster than a snowman in July. Mars, on the contrary, will turn you into an ice popsicle within seconds. But chances are, it might have been pretty hospitable at some point. Some scientists believe that Mars used to be covered with flowing rivers and lakes and had no water shortages. Even today, Mars still has an ocean called Oceanus Borealis, or rather, the remains of what once used to be an ocean. It lost nearly all its water over time. Now, the sources of water on Mars include polar ice caps and minerals and rocks. According to estimates, only 1% of all that water evaporated, while 99% is still locked in the red planet. Ice polar caps are pretty simple to understand, as we have the same thing on Earth. But rocks containing water? Simple. There are at least 4 types of hydrous minerals on Mars. There are hydrous clays made of silicon oxygen, and the cool thing about them is that they can even contain magnesium and iron, which are sulfur-based hydrous sulfates. Now, don't you? I know you thought of the smell of rotten eggs. But it's typical of hydrogen sulfur and not just sulfur. These minerals have water incorporated right into their chemical formulas. There's also hydrous silica, which has water locked in its formula too. Scientists have experimented with growing plants using Martian-like conditions and found success with alfalfa. Harvesting alfalfa also helped improve the growth of other crops like turnips and lettuce. While water may be available on the red planet, the air on Mars is mostly carbon dioxide. On the bright side, and we are, the Mars Oxygen In Situ Resource Utilization Experiment, the Mars Oxy, can produce oxygen on Mars, which could be crucial for future missions. As for energy sources on Mars, solar, wind, and geothermal energy are a few promising options. Solar power is less effective on Mars due to weaker sunlight and dust storms. But wind power and geothermal energy could serve as reliable alternatives. With these sources in place, humans could potentially sustain life on Mars. But let's get back to comparing our sibling planets. While both Mars and Earth have moons, and Mars even has 2 of them, Venus has 0, just like Mercury. Due to its proximity to the Sun and the star's gravitational pull, Mercury lacks the ability to retain its own moon. The likelihood of any moon orbiting Mercury either colliding with the planet or being drawn into the orbit of the Sun is high. That's all clear and understandable. But the absence of moons around Venus remains an unsolved puzzle for scientists. Despite Venus's scorching hot temperatures, scientists think that even today it might not be as hostile to life as we once thought. A recent MIT study found 19 amino acids surviving in a Venus-like solution for the whole month. Yep, some like it hot. Also, Rocket Lab and the Massachusetts Institute of Technology are teaming up to send an uncrewed spacecraft, Venus Life Finder, on a mission to Venus. This spacecraft will search for signs of life in the Venusian atmosphere using a special instrument called an autofluorescing nephelometer. And no, I didn't make that up. Originally set to launch in 2023, the mission is now pushed back to December 2024 with arrival at Venus in May 2025. The goal of the mission is to discover organic compounds in Venus's atmosphere, which could point to the possibility of habitable conditions in the cloud layer. The spacecraft is designed with a Photon Explorer cruise stage and a compact atmospheric probe equipped with that nephelometer thingy. The small probe will descend through the Venusian atmosphere, collecting data on cloud particles and organic compounds. In 2020, scientists made a big announcement about finding phosphine on Venus, a compound that could be linked to life. While they're still working on confirming this, using information from telescopes or even past missions, there might be evidence hidden in old NASA data received from Venus that could shed more light on the discovery. The potential presence of phosphine on Venus has stirred excitement and caution among scientists. To make sure, they need more data from telescopes or new space missions. If they find this gas, it might mean there is some form of life producing it in the planet's clouds. This discovery would be a huge step toward understanding Venus better. Some experts think that sending probes to Venus to directly detect phosphine would be the most effective way to confirm its presence. An 80s NASA mission may have already detected phosphine, but scientists back then didn't realize it. Now, this data is being re-evaluated to uncover any overlooked evidence of the presence of the gas. This could also suggest that the compound has been in Venus's atmosphere for decades, raising questions about its source. But not everyone is convinced of this interpretation, which evokes a debate among scientists about the true nature of the detected gases. Old data from other missions may also hold clues about phosphate on Venus. While new spacecraft are going to explore the planet, it's possible that the key to unlocking this mystery lies in decades-old mission records. In total, there have been 46 space missions to Venus, including some flybys where gravity lent a helping hand. The last time we successfully landed a spacecraft on Venus was way back in June 1985 as part of the Vega 2 mission. So, let's see what Venus Life Finder will discover.